All right, in this video, I'm just gonna, hit the highlights of how we use graphs to solve inequalities. How do we interpret the graphs to solve the inequalities? In the previous video, I solved several examples, but I just want to make it absolutely clear how I was using the graphs in those videos. So I've got a few examples kind of queued up for us here. We're going to do it all on this Desmos widget, just to emphasize the things that we need to emphasize. And you can look for all the details of how to write it out yourself in the previous video about this topic. All right, so again, the topic is solving quadratic inequalities, and the first one we're going to solve is this one right here. So x squared minus 5x plus 4 is less than or equal to 0. And so again, the approach is to think of the left-hand side here as a function, right? So this x squared minus 5x plus 4 is this function. We're calling it f of x. And remember that in order for this approach to work, you need this 0 on the other side of the inequality, okay? So as long as you have that set up that way, you can interpret this problem as a graphical problem where what we really care about is the graph of this quadratic function, whether it opens upward and downward, or where the x-intercepts are. All right, so let's just quickly get Desmos to show us the graph. We can see the intercepts right away. Thank you, Desmos. The intercepts are 1 and 4, right? So again, the focus of this video is just how do we interpret this graph to tell us the solution set of the inequality. Okay, the first thing we look at to get that solution set is the type of inequality. This inequality is a less than or equal to inequality. And so that means that we're looking for the portion of the graph that is below the x-axis. That's this portion starting at 1, ending at 4, right? And that indeed is our solution set. So let me highlight the solution set for you, okay? This is the part of the x-axis that contains the x values such that if you plug them into the function, you get negative values. In other words, that the values that are below the x-axis, right? Or the values that lead to coordinates below the x-axis, right? Okay. And finally, since it is a less than or equal to, we know that we have to include the endpoints on the interval, all right? And that finishes it off, okay? So this is the solution set. If I were to write this as an interval, I would write open square bracket, then 1, comma, 4, and then close square bracket, okay? And that would be the interval. That's the interval of x values between 1 and 4, including 1 and 4, all right? Okay, so let's think about another example. Okay, in this example, we're going to consider a very similar inequality, x squared minus 5x plus 4, but this time we're asking when is that greater than 0, so strictly greater than. So again, we use this function, f of x equals x squared minus 5x plus 4. Let's get that graph up there. Again, and now we know that since we're talking about greater than, we're looking at the parts of the graph that are above the x-axis. So that's this part of the graph. So there are two such parts, right? This part of the graph and this part of the graph. All right, we have the same two x-intercepts, right? So those are going to be involved. Let's go ahead and highlight the solution set. You see that? So it's the values on the x-axis, right, that correspond to these parts of the graph that are above the x-axis. All right, so and finally, we note that since this is a strict inequality, a greater than inequality, as opposed to a greater than or equal to, right, we have the open dots, right? We have the open dots, meaning that the values of 1 and 4 are not going to be included in the solution set, okay? So let me actually write down the solution set, just one sec. Okay, so I've got my little paint widget out, and I'm just going to start writing down the interval. So because it goes, it goes way off to negative infinity, right? It starts out back at negative infinity. I start with a open parentheses, now comma, where does it stop? It stops right here at the first x-intercept, which is 1, right? And so I go up to 1, and does it include the 1? No, it doesn't include the 1 because, again, it is a greater than, a strictly greater than inequality, right? So it's not going to include the 1, so I'm going to have the rounded parentheses, and then I'm going to write a union sign, and I'm going to pick up at the next intercept, which was 4, and then comma, positive infinity. Okay, so that's going to be my solution for this example. All right, so negative infinity to 1, union 4 to infinity. All right? So we see how that is displayed here in the graph as well. All right, so let's do one more example. Okay, last example. Let's solve this inequality. Negative x squared plus x plus 2 is less than 0. All right, so again, we think of the left-hand side as a function. Let's get that graph up there. What we care about is whether it's opening upward or downward. The negative coefficient on x squared tells us it's going to open downward. We see that in the graph, right? And we care about the x-intercepts, right? The x-intercepts happen to be -1 and 2, right? So let's see the solution set. Notice that it's less than 0, so what we're going to get is a solution set that as the intervals on the x-axis that correspond to the parts of the graph that are below the x-axis, again because it's less than 0, because the inequality sign is less than. All right, so let's get that on the board here. All right, so we see this is the form of the solution set. The only remaining question is whether or not the endpoints are included. Again, that comes down to the sign of the inequality. It's a less than sign, and so we see that the endpoints are not going to be included. All right, so we put these little open dots on them, and we write down our solution set as follows. All right, here it is. So again, we start with negative infinity, open parentheses, negative infinity, comma, up to the first x-intercept, the smallest x-intercept, which is -1, right? -1, that's this x-intercept here, right? Then we skip over that interval in the middle, and we pick up the next interval in the solution set, highlighted in green, which starts at 2 and goes all the way out to infinity, of course, not including the 2. So using the rounded parentheses. All right, hope that clears up everything. All right, good luck. And again, look for the assignment on D2L corresponding to this lecture. Okay.